Okay, so this week what we are doing is on confidence interval, which is your tutorial 7. So for the quiz next week, next Friday, is up to inclusive of this chapter. Okay. So what really is confidence interval? Anyone can explain? What is really confidence interval? Anyone? Okay, confidence interval itself, right, is you're asking this type of question. Okay, it is so let's say how confident, put it in layman's terms, is how confident or how sure you are that a parameter, okay, this parameter can be either the data point or the average, is within a known value. So this is one way of looking at it. Okay, you can even look at it, for example, right? So you can say that how confident or how sure that the average height of 18-year-old males is between, let's say, 170 to 175 cm. Okay, then your answer will be that you are 80% sure, 80% confident, or something like that. Okay. Okay, another type of question that you'll be asked is, this is the second type, how confident, or not sure how confident, given a range. Okay. I'm going to put it a different way. Okay. Okay. So what is the range that you are, let's say, 90% confident that a parameter will fall under? Will be in. Okay, so in this type of question, you are looking at, for example, what is the range that you are, let's say, 90% confident that the average height of 18-year-old males will be in. Okay, so here your answer will be something like between 170 to 175 cm. Okay, it's asking two different sides of the same coin. So that is what confidence interval at the end is really talking about. Confidence interval is, there's actually two parts. One is the confidence. The second part is the interval. So you make sure that you have these two components first. And what determines the confidence and the interval is based on sample size. So sample size is very important in confidence interval. Okay, so let us just grab an example first. Okay, so let's say you have a certain value. Okay, so let's just put it, so the question is, how does sample size makes a difference? Sample size is your n, makes a difference with the confidence interval. So if we look at this axis in itself, okay, and we say that here, this is the range for, so our black line is n equals to maybe 50. Okay. So this is, maybe we say that this is the height. Okay. So this is the average height. So how we use confidence interval is we use a range. So let's say if I want to have 90% confidence interval, that means the area under the curve should cover 90% of the whole thing. Okay. So let me just color this up. So this shaded area is, let's say, 90%. All right. So this shaded area is 90%. Now, then what I need is, I have to convert this into, let's say, a z-axis. So a z-axis, or even if I do a t-axis, it doesn't make a difference. I will have to find out what is the corresponding value for these 2 points and x2. Based on each side will have only 5% area. 5% area. So far, so good. So you have to be able to convert between these two axes. Okay, so this is a very important step. Now, this relies on your standard deviation or your standard error. Okay. So if the sample size is low, let's say if the sample size, we take another color, if the sample size is now n equals to 20, then the peak is also the same, but the graph is actually more stretched out. This horrible looking one. The graph is more stretched out. Okay. And as a result, the 90% confidence interval is actually a much larger range. So this is the 90% confidence interval. It will cover a much larger range because the blue line is more stretched out. And because of that, you realize that for the blue line, you need to have a wider confidence interval. That means the width must be wider. Okay, and this is why sample size makes such a big difference, which generally means that the smaller the sample size, the width of the confidence interval is larger given the same confidence. Okay, that's one way of looking at it. Another way to look at it is, if you want to the range, that means x1, x2 remains the same. So if, let's say, this still remains the same, that means you reduce the confidence. Okay, so the smaller the sample size, the lower the confidence given the same width of the confidence interval. So far, any problem with this concept? That means sample size, it depends on whether you want to be more confident or less confident. The width will change. If you want to keep the same width, then the level of confidence will change. So there are three parameters. Here there's three parameters. Okay, sample size. One is sample size. Two is the confidence level. That is the width of interval. You can only pick two to remain constant. The third one will automatically have to change. So far, any problem? Hello? Okay? Know what's happening?
Okay, Cha.
Okay, good. All right. Okay, so let's do our, let's see, what else do I have to say about this thing? And where on earth is my stuff? Okay, let me just go to here, pictures, open it up. Okay, so there's actually one more component which I haven't said is, what is the difference between data point and mean? Okay, so there's actually two things: confidence interval of the data point versus confidence interval of the mean, that means the average of the data points. Okay, I keep stressing this. It is very similar to when you're doing your t-test. Okay, when you're doing your t-test, whether are you to find, you're finding the probability of a data point, or you're finding the probability of the mean of the data points. Okay, so this is actually quite important. Why do I keep mentioning this aspect is because the confidence interval of the data point, we use it quite often. We use this thing as the reference range in your medical biology. Okay. So for example, let me just give you an example. Okay. If you take, let's say, 100 healthy males aged, let's say, 18 to 25, okay, and you estimate that the average, let's say, your systolic blood pressure is, let's say, 80. Your average systolic blood pressure will be 80. Average systolic blood pressure is, let's say, 100 millimeters mercury. To give just an example. And the standard deviation for the blood pressure, systolic blood pressure, is, let's say, 5. Okay, I can ask you two different things. I can ask you two different questions. So let me just use different color. I can ask you one question is, what is the 95% confidence interval of blood pressure? Okay, here talking about systolic blood pressure. What is that? In other words, this is you're talking about, you're actually saying that it's actually one person. Okay, so you can build the confidence interval in this case. The 95% confidence interval is actually 100, okay, millimeters mercury plus minus 1.96 times your standard deviation. Okay, so in this case will be roughly about, so about 2, this is nearly about 2, so 5, 2 will be about 10. So it is about 91 to 109 millimeters mercury. Okay, and we use this as the reference range. The second type of question will be in this format. Let me choose green color. So the second type of question is, what is the 95% confidence interval for an average what is the 95% confidence interval for an average systolic blood pressure for, let's say, 100 healthy males. In this case, you are looking at the average of a group. This you're talking about one person. Oops. Poor coloring. This you are talking about one person. This you are talking about average of a group. Okay. So here you have the 95% confidence interval. It's actually 100 plus minus 1.96, but instead of using the standard deviation, you have to calculate the standard error. So the standard error of blood pressure is actually 5 divided by square root of 100. In this case, you got square root of 100 here. which then gives you 0.5 millimeters mercury. So here is multiplied by 0. Oops. 0.5. So which is about, this is 2 times 1, which means it's about 99.1 to about 100.9 millimeters mercury. That is the average. Okay. So please keep this concept in mind. You're talking about question, the red color question, you're talking about one person, the green color question, you're talking about average of a group. Okay, so these are very important concepts. Please do not mess up.
Sure.
Yes,
just to confirm, the red color one, the reason why the confidence interval is larger is because the sample size is smaller. And conversely, the green color question, because the sample size is larger, the confidence interval is smaller.
No. The red color one is because you're talking about one person. It's not talking about the average of the group. You're talking about what is the confidence level. That means what is the 95% confidence interval that, or what is the range that you are 95% confident that a single healthy male will have the blood pressure within this range. While the green color question, you're talking about what is the confidence, what is the range that the average of a group of 100 healthy males will fall within this range.
Oh, okay, got it.
Okay, so this is an important concept. Please do not mess it up. Again, take my hint, do not mess it up. Okay, so with that, that's all about confidence interval, nothing very much. Then we can do our tutorial questions now. Okay, so our tutorial question 2. Let's start with question 2 first. Anybody can answer question 2. That color. Anybody can answer question 2 or tutorial question? Anyone? What am I doing here? What is this? Hello. Let's see. Avina?
Question 2 I wrote for confidence interval, I just write it's a estimate of parameters by using the data obtained from a sample.
Okay.
Then for hypothesis test, I just say determine like if two variances are equal.
Okay. So it's somewhat correct, not the full answer yet. Okay, for confidence interval, what you are providing a range that a population parameter, okay, in this case could be the average or the mean, falls under. So you're actually providing a range. Hypothesis testing is actually a decision. So there are different sides. There are two sides of the same coin. Hypothesis testing is decision. Your decision is either a yes or a no answer. It's a binary answer. Confidence interval provides the range. Okay? Because remember, hypothesis testing, you actually require one thing called your threshold, or usually it's the alpha value. It's based on the threshold you come up with a decision. Confidence interval doesn't have a decision. That means in confidence interval, there is no hypothesis. You're not actually testing a hypothesis. Okay? So question 3. What is the best interpretation of of 95% confidence interval for the mean? Okay, anybody? It's actually directly from your lecture notes. So, Rachel?
We are 95% confident that interval from x to x contains the true value of population mean.
Alright, you're 95% confident that true value. Okay, so what you say is you are 95% confident that the true value of population is within, let's say, x1 and x2, right? Is that what you say?
Yeah.
Yep. Okay, so it's actually not wrong. It's actually a correct interpretation, but it's actually not the best interpretation. Okay? So I'm not saying that it's wrong. The way to make it wrong, the word here is confidence. But if you change this confidence, to probability, okay, then it will be wrong. Okay, I think it is in where on earth is the notes here? So you have actually this misinterpretation. So the first one, okay, 90% chance means 90% probability. So that is wrong. Okay. So what is the best answer for this? Let me just get to here and okay. So the best answer that you can give is if you take repeated samples, repeated or multiple samples. Okay. And calculate 95% confidence interval for each sample or each of the repeated sample. Okay. Then 95% of these intervals will contain the true population mean. Do you understand the difference? Hello, anybody? Okay, the reason here is because you don't know what is the real true population mean. Okay, so how do I draw it out graphically for you to see is this? So let's say, in this case, so for example, let's say this is this just okay, do a different coloring. Let's say this line represents the true population mean, okay, whichever value is. So what you are really doing is you can collect samples. Okay. So sample 1, your 95% confidence interval may be here. Sample 2, your 95% confidence interval may be here. Sample 3 may be here. Sample 4, confidence interval is here. Sample 5, confidence interval may be here. Sample 6, confidence interval may be here. Sample 7, confidence interval may be here. 8, confidence interval is here. Sample 9, confidence interval is here, and so on. So you go all the way to sample n. Okay. And then you say that out of n samples, 95% of the n confidence intervals will contain the true population mean. That is what confidence interval is saying. Because why? You have this is the one that doesn't contain the population true population mean. This is the one that fails, doesn't contain the true population mean. The one that contains the true population mean will be this, 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 and this. Okay, so you have to do a lot of multiple samples in order to get that. Okay. Any problems with this concept? Okay, so with that done, let's go to question number 4. Okay. Question number 4, you have a random sample of 70. Okay, and you survey the number of hours that you sleep. The mean is 7.1 hours. The standard deviation is 3.3 hours. Okay. A, what you're trying to do is you're trying to find the 95, not 95 yet, 90% CI of the average sleep time. Okay, so what is the confidence interval? Give me the answer. Just give me the answer first. Okay, let's have who have it? Vivian?
For A, my answer is 6.45 to 7.75.
Correct. The answer is 6.45 to 7.75. This is correct. Okay. So how do you work it out? Let us just work out the examples. You are taking the average minus, you use Z distribution because the sample size. So you say that since n is more than 30, you can use the Z distribution. Okay. Minus the Z distribution for 0.05 times the standard error. So standard error here will be 3.3 divided by square root of 70. Okay. And here will be plus 0.05, 3.3 divided by square root of 70. So here you end up with 7.1 minus 1.65 okay, times 3.3 over square root of 70, 7.1 plus 1.65, 3.3 divided by the square root of 70, and that will give you the answer. Okay. So with that, B and C should not be a problem. 95% confidence interval of the average sleep time. That must be sleep. Okay, Lawrence?
For B is 6.33 to 7.87.
Right. Okay. So in this case, you're using Z is 0.025, and this gives you 1.96. So essentially what you're doing is you just change this value, okay, into 1.96. Okay. So C, 99% confidence interval of sleep time. Okay, let's see who else have I not heard. Okay, let's see. Who's unnamed? But the rest are unnamed. Keith. Keith, where are you?
Roger.
Yeah. Answer?
Answer
Yeah.
for the part C is 6.08 to 8.12.
Correct. So in this case, we are using Z equals to 0.005. That gives you 2.8, 2.58. Oops. Yes, no problem. Very good. Okay, question number 5. Question number 5. You can just provide me the answer, because if you don't answer and everyone got it right, then you should know how to do it already. Ying, Jing. Question number 5, Jing.
Sorry, what?
Question number 5, what's the answer?
Wait ah. 848 to 11.5.
Correct, 11.5. Yeah, this is correct. Okay. Why do you use the, here, question number 5, you have a random sample of 20, but why do you use n equals to 20? So why do you use Z distribution instead of T distribution? Ying.
What?
Why do you use your Z distribution instead of T distribution, since your sample size is less than 30? This is my question. Since the n is less than 30, why you use Z distribution instead of T distribution?
Wait hold on Of course, like the population variance is like known.
Yes, correct. Okay. It's because the population variance is known. Yeah, that's the correct answer. Okay, in fact, this answer is correct, no problem. Okay, so question 6. Okay, question 6. Let's see, have the next person. So, who shall we call? We have Tansin.
Four 7.1.
471. Hold on. So do you use T distribution or Z distribution first?
T.
T, okay, so you use T distribution. Then what is your degrees of freedom?
0.005.
No, degrees of freedom. Yeah, your alpha is 0.005. Degrees of freedom?
19.
Correct. So your answer is?
2.861.
Okay, so it is actually using this, right? Your T 0.005. 19 is 2.861. Correct. Then what is your final answer? What's the range?
471.7.
Here is 471.7 to
486.3.
Yeah, correct. Okay. So in this, how do you get to this point? Is you take 479 minus 2.861, okay, and this 131 divided by 20 to 479 plus 2.861, 131 over 20. Okay, correct. Okay. 6, 7. Okay. Oops. Why am I saving it again? All right. Question number 7. Question number 7 says that a lecturer is tired of seeing students looking at phone more often than looking at lecture materials, which is always the case. That investigate the amount of time, yeah, so on and so forth. Find the 90% confidence interval. So A is you want to find the 90% confidence interval of the mean time. Okay. Okay, so let's get somebody else. Gerard.
Sure. So the answer is 105.62 to 108.38.
108.38. Okay, correct. So you use Z distribution or T distribution?
Z, because variance is known.
Yep, Z distribution because variance is known. Okay. Known. Okay. Then what you're doing is you're thinking about Z 0.05 equals to 1.65. Okay. So in this answer actually comes from the mean, which is plus minus 0.05 and your standard error. So here is 107 plus minus 1.65. Standard error is square root of 35 over 50. Correct. Okay. Part B. Okay. Now, part B, it turns out that only 27 students provide accurate results. Okay. Turns out that only 20. Actually, this is Gerard, this is wrong. You use Z distribution, it's not because the population variance is known, it's because the sample size is more than 30. Because you read the question, he obtains a sample mean of 107 minutes.
Oh, sorry, that's my mistake. Okay.
So it turns out that only 27 students provide accurate results. So what is the 95% confidence interval of mean time? Okay, so let's get another person. Minli?
Yup,
What's your answer?
for BA.
Yeah. Okay, do step by step. Do you use T distribution or Z distribution?
Yeah, can I just tell you my answer?
I can. Okay, give me your answer first. If your answer is wrong, then we'll talk about it later.
Okay, my answer is 89.2 and 92.8.
92.8. Okay. Yeah. All right. So back to the question. Do you use T distribution or Z distribution? Anybody can help her? Ishana? For question 7B, do you use T distribution or Z distribution? Hello?
Is it T distribution?
Right. Why do you use T distribution? Yeah, it's correct. But why do you use T distribution?
The sample size is less than 30.
Correct. Because sample size is less than 30. Okay. And because in fact sample size equals to 27, therefore the degrees of freedom is actually 26. Okay, and that's where you get this answer. Okay, so your T 0.025, degrees of freedom of 26. That gives you 2.056. Okay. So here, the question actually gives you another, the mean is actually 91 minutes, and the sample variance, smaller variance is actually 22 minutes. Okay, so this answer comes from plus minus T 0.025, 26 of your standard error. Oops. 225, 26 of your standard error, which is then 91 plus minus 2.056. Standard error is your 22 divided by 27. Okay, great. Last question. Okay, last question. A chemist wants to investigate the amount of acetone in a bottle of 1 liter window cleaner from a company. Okay. So, a random sample of 100 bottles were analyzed, and the mean is 22 ml per bottle of acetone. The standard deviation is 2 ml per bottle. So question 1, but A, you want to construct the 90% confidence interval of the mean amount of acetone. Okay. So who shall we get here? Joey?
Yes.
Yeah, so what's your answer first?
Sorry?
What's your answer for 8A?
I haven't reached that part.
Haven't reached that part. Okay. Okay, then we'll skip you, but be sure you do. Okay, Marcus? Marcus. 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 Hey, where's Marcus? Okay. Zuri.
Which question was it?
8A.
21.67 to 22.33.
67 to 22.33. Correct. Okay, per bottle. Okay. So how do you actually get here? Okay, because sample size is 100 bottles, you can use your Z distribution because your sample size is more than 30. Okay, and what you want is 0.05 is 1.65. So how you get the answer is actually 22, which is the mean, minus 1.65. The standard error is 2 mils divided by square root of 100. Okay, 22 mil plus 1.65 to divide by square root of 100, which is square root of 100 is 10. Yeah, that's you get the answer. Okay, so part B. What will happen to the width of confidence interval if the confidence increases from 90% to 95%? So will the width be larger or smaller? Okay, this should not be, should be quite okay. Xuan Wei. Hello. Xuan Wei, are you there? Okay, Faith.
Larger.
Yeah, so this will be larger. Okay, so since you're here, answer C as well. Okay, so the cup, if the label is 20 ml of acetone per bottle, okay, is the claim reliable? That means, is it actually 20 ml per liter, per bottle? Based on 90% confidence interval. So yes or no first? Okay. Vivian? If I call you already? Not sure, huh? We'll try. Vivian? Vivian. Vivian. Okay. Where did all of you go to? Marcus, are you still alive?
Is it unreliable?
Huh?
Is it unreliable?
Unreliable. Yeah, Jane, correct. It's unreliable. No, it is not reliable. But what is your reason? Jen, what's your reason?
Cause the thing the 20 ml doesn't fall between the confidence interval at 90%.
The label, which is the 20 ml, does not fall within the range of your 90% CI, which is actually, you already mentioned, it's 21.67 to 22.33 mils. Correct. So that's the reason. So what it really means is, if you base on this, right, confidence interval is actually equivalent to the non-critical region. Confidence interval is actually the non-critical region. Okay, so what happened is, let's say you draw let's say this is your confidence interval. Okay, and this is the 90% confidence interval. So this is the amount. And here you have 21.67 to 22.33. The non-reliable is when it's out of the critical region. So remember, this is the critical region. This is the critical region. So your confidence interval basically means that it is the non-critical region. Okay. And actually, that's the relationship between confidence interval and your test, your hypothesis testing. You can use confidence interval in your hypothesis testing if you know how to do it. All right. So, okay. And since we are here, so let's do your question 1. Okay, question 1A, the true-false question. Okay. If you're finding the 95% confidence interval for a population mean, an increase in the sample size will result in the decrease in the width of confidence interval, true or false? Anybody just answer? Okay. Jody? Joey. How to pronounce her name?
Correct. Pronounce correct.
Okay. So what's your answer? True or false?
Sorry, can you repeat the question again?
It's 1A.
Sorry?
You're finding question 1A. The true false question 1A. You're finding, yeah.
True?
True, correct. Okay. So an increase in sample size, you reduce the width of confidence interval. Okay. Then question 1B, is it true or false? Let's find somebody else. Nadia?
True.
True, correct. In fact, question 1A and 1B is the same thing. Okay. Question 1C, if you are finding 95% confidence interval for a population mean, to halve the width of the confidence interval, you have to halve the sample size. True or false? Effa?
False.
False. Okay. In fact, there's no such thing. Okay. Question 1D. Confidence interval can only be computed for the mean. That means you can only calculate for the mean. Is it true or false? Lawrence?
True.
Huh? True? False. Because remember, we can calculate confidence interval for a data point. It may not always be the mean. Okay. So please be careful with this. Okay. Question E. The statement, the 95% confidence interval for a population mean is from 83 to 90 is equivalent to the statement there is 95% probability that the population mean is between 83 to 90. True or false? Rachel?
True, true.
False. False, false, false. False, not true, Okay. Remember, the error is not okay, to make it true, right, is that the equivalent to the statement there is 95% confidence that the population mean is between 83 to 90. It's not the 95% probability. You understand why you get it wrong? Rachel?
Yeah.
Okay, so please be careful. All this is a trick question. In fact, true false is more of a trick question than anything else. Okay. So please revise carefully. It's covered in your test on Friday next week. Any questions so far? Okay, let me just bend my laptop over. Just one of these days, the computer, my laptop screen is going to be just broken into my hands. Okay, where's my mouse? Mousey, where are you? All right, any questions so far? What am I here?
Sure.
What?
For question 1 part D, why is it false?
Okay, because confidence interval can be computed for data points as well. So let me just show you this. See, this is the part, the red color question. It can be computed for a single data point. It may not always be computed for the average. That's why it's false. Okay?
Okay.
Yeah, that's the
Okay,
reason.
okay.
Yeah. Okay. All right. Any other questions so far? Okay, if not, then that's all for today. Have fun. Bye-bye.
Thank you. Bye bye.
Bye.
Thank you. Goodbye, Joe.